Today we'll discuss about the transition delay. Transition delay means the transition on the particular node does not produce an expected result when the system is at the maximum speed of operation. Transition delay fault models are two types. One is slow to rise and other one is slow to fall. Slow to rise means when the system is at the maximum operation speed, it unable to produce a transition from 0 to 1 at a particular node. This is known as slow to rise. Slow to fall means when the system is at the maximum speed of operation, it fails to transit from 1 to 0 at a particular node. This is known as slow to fall fault. Transition delay fault testing approaches are two types. One is launch on shift and other one is launch on capture. For launch on shift and launch of capture, what the term means launch. Here launch means the launching the desired logic at the output of the node. If I want to launch a logic 1 here, I will force a logic 1 at the input of the AND gate. Since one of the input is logic 1, the output will be logic 1. Similarly, if I want to force a logic 0 at the output node, I will force the input signal with a logic 0. So it will launch a logic 0 at the output node. Discuss about launch on shift. Launch on shift means the launch pulse is forced on shift cycle. So let's discuss about the operation, how the launch on shift works. Here this is a simple circuit which has the 4 flops and the combinational circuit will have a simple AND gate with one of the input tied to logic 1. If I want to launch a logic 1 at the output of this AND gate, I need to force 1101 shift in cycle as shown in the diagram. Then the logic 1 will be forced at the output of the AND gate as shown here. Since I am trying to figure out slow to fall signal at the output of the AND gate, I am forcing a logic 1 at the output of this AND gate by using shift in cycles. So after the shift in cycles, now I am launching the capture cycle. Here the capture cycle, the output of the flip-flops will be traveling through the combinational circuit. So the logic 0 will be applied to the one of the input of the AND gate and the logic 0 will be getting as the output from the AND gate. So the signal will be propagated down, means it is going transition from 1 to 0 as shown here. Now I will apply the 4 shift cycles and shift out the rest of the signal. Now I applied the 4 shift cycles and scan out all the data which is residing in the flip-flops. So for the passing region, the output will be logic 0. So for the failing for the failing pattern, the output will be retained as logic 1 at the output of the AND gate. Now here where the transition fault is tested. In launch on shift, the scan enable is the one which has the property of testing the transition fault on the circuit. When the scan enable is high, it launches all the required data in the flip-flops. Whenever the scan enable goes low at speed, it applies the logic residing in the flip-flops at speed to the combinational logic to test the AND gate at the maximum operation speed. So always in LOS, The scan enable should be operated at the maximum speed of operation. Launch on capture works. First, I will explain this circuit. Here, I want to test a slow to rise signal at this particular AND gate, and my circuit has S6 flip-flops. So this is the scan path, and the rest of the circuit is the combinational logic path. So since I want to test a slow to rise signal at this particular AND gate, I want to launch a logic 0 at this particular node. So for this, I am making a scan enable high for the 5 clock signals and passing the data 0 0 0 0 0 1. So all this data will be appeared to the flip-flops as shown in the figure. So next I am applying the capture pulse. As soon as I apply the first capture pulse, the logic 1 and 0 here will be applied to the OR gate, and the output will be logic 1, and the logic 0 will be applied to this NOT gate, and the output will be logic 1. At the same time, when these logics are applied to this combinational logic, that data which is presiding in this flip-flops will be applied to this AND gate at the same time. So 0 0 and operation will be logic 0 will be applied to the same time as 1 0 is applied to this combinational logic. So at the end of first capture pulse, then updated values in the flip-flops will be 1 1, and here the logic will be 0. So by using this capture pulse, we are launching the 0 transition 0 logic in this particular node. Now I will apply the next capture pulse. As soon as I apply the next capture pulse, the 1 0 will be applied to this OR gate, and 0 will be applied this to the NOT gate. So the latest values will be 1 1, which will be overwriting with this previous logic 1 values in this residing flip-flops, and this 1 1 logic will be applied to this AND gate, and it will go transition from 0 to 1. Now here we can notice that the capture pulse is launching at high speed. So this AND gate is tested at speed, and the output of this AND gate will be propagated to this flip-flop. Now I will apply the 6 clock pulses by making the scan enable high and pump out all the logical values which are residing in the flip-flops. So the output response here is logic 1 will be propagated into this flip-flop, so which is this one. So if a test fail, it will be residing as logic 0 only. So by this, we are doing the launch on capture by testing the circuit at speed.